We have to start so that we are not out of the time for this morning. My name is James Chirongo again. I'm chairing this, and the one I have to announce, to introduce, is not a new person in this community. He's been with us for many, many, many years. And I was just looking at it and says, some time ago, he will disappear to attend our conference, and this year we managed to catch him, and he's not running away, he's with us. Gregor Fake has been with us like so many years, like I said, and he's one of the managers at SAEO. That's the stakeholders that reports to NRF. For those who wants to know more of that, you can also go on website and understand what they do there. Today, this morning, he will be sharing a talk on a landscape scale environmental research infrastructure in South Africa. And this is based on what the company is doing and what they've been doing for all these years. And I think we were talking, myself and him, yesterday to say it has been for many years since he started this work at SAEO. And it's almost like, how many years? 5 years, 10 years? 7 years. He has been working on this work. So we will see a lot of activities that they have been doing for the last 7 years in this work. And it's more related to us as NACA, so that at least we can understand what kind of research is happening there. So I would love to say over to you. You have got 20 minutes to give us your talk.
Okay, thanks. Yeah, thanks. So good morning, colleagues. Am I going to see a screen? Yeah, here it is. Okay, and just... Morning, colleagues. My name's, as James mentioned, my name's Gregor Feig, and it's really great to be back. I've been involved with NACA for probably since 2010 was my first NACA. 2011 was my first NACA conference. And I've been part of this community for a long time, and it's really great to be back. It's been a while since I gave a presentation. So I'm going to be talking about basically what we've been doing at SAEON that relates to air quality for a while, and a research infrastructure that is being set up within SAEON called FTON, the Expanded Freshwater and Terrestrial Environmental Observation Network. And I'm giving this presentation to cover work that we've been doing, but also my colleague Warren Joubert is around, and I don't see him in the room, but he's actually leading the atmospheric composition and meteorology component of the infrastructure. So please send some questions his direction. Okay, so the last time, I don't know if it was the last time I was here, but in the Clean Air Journal of 2018, we gave a commentary on this plan on the research infrastructure, the FTN research infrastructure that we're going to be putting forward. And we made a whole lot of promises about, this is what the idea was and this is what we were going to be doing. And we promised, a set of standard automated measurements looking at exchange of carbon, water, and energy. So this is a kind of classic flux measurement kind of work. Observations around the water cycle, meteorological and air quality kind of measurements, and then a network of manual measurements of biodiversity, ecoservice provision and use. We promised free and discoverable data sets, and we promised that there would be 6 research infrastructure landscapes working at about a 100 by 100 kilometer scale, so that you can start getting these changes within like some of the important biomes in South Africa. And then we thought we'd say something around inputs and disturbances, including things such as deposition. So that's what we promised right at the beginning, once the proposals had been put through and funded. So just a little bit about where we are and how the hosting of all of this works is I'm at SAEON, which is the South African Environmental Observation Network, and this is part of the NRF. So most people are familiar with the NRF as funders of research, but one of their aspects is also providing the facilities to do research. And SAEON is a facility that does long-term integrated environmental observations. And that's really what we try and do. Started off with a very strong biodiversity bent, moved into hydrology as it developed, and is now expanding across some of these other spheres. The vision of SAON is a world-class environmental research platform for sustainable society, and we are dedicated in enabling long-term in-situ global change research. So parts of the NRF give money for students. We provide the platforms for doing research on those platforms, or we try to provide that. As SAON developed and as the science landscape developed, the DSTI funded a network of research infrastructures through a program called SARIA, the South African Research Infrastructure Roadmap. And I think there are 14 research infrastructures covering a whole suite of different aspects, from digital languages to a variety of other things. And there are 3 which are associated with long-term environmental research. So, and they're all hosted at SAON. This includes FTION, which I'm going to be going on about today. There's our sister infrastructure called SMACRI, the Shallow Marine and Coastal Research Infrastructure, which operates on the coastal systems of South Africa, and then South African Polar Research Infrastructure, which goes into the southern oceans, the sub-Antarctic islands, and through to Antarctica. And that's, of course, in collaboration with DFFE and the use of the Agulhas and various others. And basically what we're doing in South Africa is getting this footprint of similar kind of observations, interdisciplinary research, all the way from the subtropics of Limpopo through the different biomes and different ecological aspects in southern Africa, through to the coastal systems, and then all the way down through to Antarctica, which I think is an extremely exciting and really ambitious program that we are doing. Okay, onto FTION itself. So this is our general map. We've got 6 landscapes in which we are rolling out development. These are the Greater Cape Town landscape, outside of Cape Town, the Kimtree landscape around Kimberley, so it's arid zone where you've got the transition between grassland, savanna, and Karoo systems. So you've got this transition and you've got a medium-sized city. The Lowveld, linking between aspects of conservation areas like the Kruger Park and some of the infrastructure that is there, and the communal systems in Bushbuck Ridge and adjacent to that, and also very importantly linking to the SAPRIN network, which is doing the population demographics within some of these areas. We have a site at Maputoland, so that's northern KwaZulu-Natal, up near the Mozambique and Swaziland border. This is one of the more tropical systems, so we can start seeing what the tropical impact might be of things like increased cyclones and extreme dependence on natural resources by that very poor community. In the northern Drakensberg region, building out of long-term research in the Cathedral Peak area, we're developing the northern Drakensberg area and the upper catchments of the Tugela River. And then what we haven't actually got much development in yet is the Garden Route landscape. To be based out of George Sarsveld campus and looking at this area where you've got a lot of transition between different biomes and different systems in a fairly confined space. So this is the idea. It captures a lot of the biomes in South Africa. It captures a lot of the urban and ecological and socio-ecological systems. Within this, we're working on 5 major platforms. So the first one is biogeochemistry, so looking at things like the exchange of carbon, nitrogen, and other compounds between the atmosphere and the land surface, and eventually into the hydrological systems. The prime piece of equipment that we're putting out there are the flux towers, and I'll go into that a little bit later. Hydrology, linking in terms of things like what the water quality is, what the water quantity is, how this flows, what those movements are, how different things like land use might be impacting that. The meteorology and atmospheric sciences, so looking at the meteorology and the climate information that kind of drives a lot of these processes that might be impacting biodiversity or various other things, and then also the atmospheric composition. And Warren is now back in the room. Warren, can you just put your hand up? He's leading this. We have a platform looking at biodiversity, so things like what is the biological template of these landscapes? How is that changing? How is that getting impact by land use decisions? And then finally, the area that will eventually start pulling all of this together is the social ecological systems component. It's like, how are people thinking about stuff? How are they planning their land use? Where do they get their resources from? And this is an area that's still, somewhat under development. Remember that these are platforms. We're trying to get some of the initial and the basic infrastructure in place and have researchers in various projects and from the universities and things coming through and using these platforms to further the development. So, we're not the be-all and end-all of this work in place. In each of the landscapes, so 4 of them are nearly fully staffed at the moment. We have a scientist who has the domain of speciality. We've got technicians who are responsible for instrumentation, making sure that the weather stations work, making sure that the flux systems are in place, the hydrology instrumentation are getting checked and downloaded and all of that kind of stuff. There's a biodiversity technician who goes out and counts plants and looks at insects and does whatever one does as a biodiversity tech. And the social ecological systems. This is an area that's still developing, but we're using this at the moment to kind of integrate ourselves into the community. So a lot of kind of social engagement, attending community meetings and things at the moment until the landscape scientist gets appointed. Okay, so onto some of the platforms. Biogeochemistry, as I said, one of the key points is the eddy covariance, or the flux measurements. So these are systems which measure the exchange of carbon dioxide and water vapor and energy between the atmosphere and the land surface. So you're basically measuring the breathing of the system. And this is one of the systems up in the Cathedral Peak area. It's a technique which is developed from micrometeorology, and in addition to this carbon exchange, we've got quite good meteorology and other information, biomet information at that site. So you link that and start building on additional work that's coming through, and you can use it as a platform. For example, at the site, there were some of the passive samples for the Mercury network, which were deployed. Some of these sites have been going since 2000. So the site at Skakuza, we've been working with the CSIR to refurbish that. And then some of these instrumentation sites have are fairly new. And this is one of the better networks in the continent. We are involved with the international groupings, and one of our technicians and scientists was recently at the FluxNet meeting in Brisbane, which is where the researchers doing this kind of work come together. So we're involved in those communities as well. We're looking at how the vegetation is changing and how this is changing every year and over time. We've got things like septometers, we're doing repeat photography, and we've recently procured some instrumentation to look at soil respiration. And these will be portable. You can put them out on various chambers under various systems, and you can get CO2, methane, N2O, ammonia, and water vapor coming out from these. So this is a skill set that we're still developing the processes and getting comfortable using them, but these will be rolling out into these landscapes in which we're operating. Within the footprint of all of these, we start trying to pull this information together. So for example, vegetation sampling within these footprints, and link that to what is happening across other parts of the continent, right? So building up the network of observations and how they feed into each other. So if you're getting carbon exchange measured on the flux system, you can start looking at what the standing biomass is measured by somebody cutting and counting or measuring the diameter of trees and that kind of work. And this is rolling out in these scapes, and this is getting repeated on a fairly regular basis, so we can see these changes and a measurement of these changes at quite high specificity. And this is what the biodiversity technicians do, is they climb into thorn trees and they get themselves spiked by thorn bushes. And yeah, so this was at Spionkop. They measured like 2,000 trees and had quite a few stitches. Linking to that is trying to develop some of the other capacity around what kind of the instrumentations are. So like acoustic sampling. So these are just sound recorders which are put out, and then using machine learning and other processes. So instead of having like a birder going out to look at birds every morning for a month, you run this continuously for 6 months or a year, and you can start processing the data, and you get a wider variety of things being identified. Hydrology, we're putting out level loggers and looking at where some of the water flow is going through, and then some of the kind of social engagement. So the top picture with the community sitting, that was a PhD student looking at land use decision making in some of the agricultural communities in South Africa. The gentleman down at the bottom, he's busy harvesting lala wine. So it's looking at like what those resources are within the community. Okay, so on to 7 minutes left, onto the air quality and meteorology component. So we're rolling out a network of met stations to support some of this information that's coming through, and these are linked into other activities. So for example, the figure on the left, which is the community in up in the northern Drakensberg, sorry, just went blank on the village name. There's community development programs, and this is information that's feeding into the agricultural development and into local schools. And then the other figure is at the Agincourt site. So this gets into community health kind of information and starts supporting that. Across SAON, we've got 181 meteorological measurement sites. 21 of these are AWSs, which are reporting live data. So you can go onto the website, which will come up, I think, now, there. And you can see the data that we've got. You can see, as of 5 minutes ago, and the flux systems are reporting on this as well. Just to, say that we are actually doing our work. This is from our last quarterly report. We're getting like 95, 98% data recovery from the, I think it's 15 sites that we're running. So, the data is being checked, the instrumentation is being maintained. The ones in the red boxes are the flux systems, which are a little bit more complicated. All this data then goes onto the SAON observations monitor. This is all the live MET data and EC data, and you can just register your email, and then you can download that data just with the CSV at different time periods, and you can explore that. So I think there are 29 stations reporting there at the moment, with I think 190 million data points on that. Part of the network, we're looking at some of the atmospheric composition platform and putting out some of the basic instrumentation coming through. First of all, working off the long-term debit studies that have been happening, so looking at wet deposition, and you can see if I can get the laser to work. That's the dust bucket system. This is one in Kimberley. There's the aerosol sampling that's getting done on a weekly basis. That's the top right picture. You can see the mini-vols out there, which is capturing samples for EC and OC analysis. That's at Spioncorp. And there's a different version of the wet deposition that's coming through. So this is getting analyzed. We're getting ideas of what the concentrations, the pollution concentrations are in the rainwater, and also data from this network of passive samples which are coming through, some of them in fairly nice locations. And this is in conjunction with Northwest University. And then one of the more recent developments is the rollout of facilities for supporting, the higher end equipment. And we've got these containers which are going to go out into each of these landscapes. These are standard air quality sampling containers, with racks and appropriate inlets and things like that. The first two have been constructed, and they're going for deployment at the MRC Agincourt site to link in with the population demographics work and the health work that's been happening down in the Lowveld. And the other one is into the Northern Drakensberg super site that we're developing at Spioncorp. So that will give a bit of a background location. We are not instrumenting these very heavily, but we're providing the facilities, the platforms, the electricity for researchers to come in and bring their own equipment in a project basis, and a reasonably sensible but not necessarily completely trained technician to keep an eye on things, right? So hopefully that becomes useful for any further studies. What we are getting are some mid-level ozone instruments, and those have recently been procured, and those will go through into each of these landscapes. Because these are an essential GCOS variable, they link into a lot of the biodiversity kind of questions and potentially the human health. So this was where we are putting some of our efforts in the atmospheric chemistry monitoring. We had this instrument out. This is University of Pretoria instrument. This was at Spioncorp. We've hosted that since 2023, so that's what, like three years worth of data coming through now. I thought this was originally time series data, but it's actually hourly per month, hourly diurnal cycle. But I think you can see that there's fairly decent data recovery there. It might be hidden a little bit by the graphs itself, but you can see that there's pretty good coverage at this particular site. And this is a University of Pretoria instrument that we've been supporting and just keeping an eye on. We do, I did mention that we're operating as a platform for further research. So we've had hosted students like Sihle, who was doing VOC measurements at one of our sites, and had based that as her measurement platform. I think she has very recently completed her MSc. The other picture there is from a recent field trip I was at in Kimberley, where we had hydrologists and the flux maintenance, and there were 3 teams in the field at the same time, which I think is really exciting to see that kind of cross-linking. And there were students from Salt Lake University and Free State, and I think there's one of the other universities as well. And then we get involved in proposals. So this is the EDSA proposal. Nomsa spoke about it yesterday and how she did her master's in this. And this is a multi-institutional team that went on this particular program looking at the fate of nitrogen and nitrogen cycling across South Africa, so including University of Pretoria, UCT, Limpopo, Northwest University, and support given by FTION. I'll skip over that. Basically, that's just the idea of what the EDSA project is about. And I think some of the really exciting stuff is coming through using the platforms that we developed, these just general sampling, which is part of our standard work. Those samples were then sent to the BioGrip lab at University of Cape Town, where they started doing isotope work on the nitrogen species. And you can see through that isotope work in the Kimberley and Spionkop sites, you can start getting a source apportionment, an isotopic source apportionment from those samples that we are taking as part of our routine observations. Warren is involved in a project with the UK, RAL Space, trying to develop a total column carbon observation system to be deployed in South Africa to help validate some of their remote sensing and the future remote sensing needs that are coming through. So this would be looking at column CO2, methane, and a couple of other species. And these are being built in the UK with South African support, and then will be deployed and will be left in South Africa at one of the sites that we're operating in. So this is collaboration between the NRF and the UK and the STFC program. So yeah, I've got 22 seconds. We're deploying an interdisciplinary approach. You can see how these things are starting to pull together. We've deployment at a landscape scale, 50 kilometers by 50 kilometers. It facilitates research at scales and between landscapes. There are implicit linkages between meteorology, atmospheric processes, hydrology, and biogeochemical processes. This is important for input to things like remote sensing and modeling studies. We include the human and biodiversity components as drivers and as respondents to these areas of environmental change. And very importantly, we are a platform for training students and developing technical skills. And of course, our whole purpose is collaboration nationally and internationally. And, sorry, that is it. There are our websites. I'll leave that on for a couple of seconds. And then I will end on the Clean Air Journal.
Thank you so much, Greg. Any question to great presentation that he gave us? Any question? This
I have one.
question.
Hi. I mean, this is a lot of infrastructure over it's a large distribution. Who's responsible and who takes care of the equipment and make sure the data quality stays as you intend it to be,
Yeah, so we've distributed our staffing. So each of those landscapes has got an office or is developing an office in which to be based. And within each of those, there's a scientist who's responsible for the kind of general operations of the landscape, make sure that things are going and technicians are going out into the field and like whatever is being done. But they also have an overview of their field of expertise. So for example, Warren, who's probably most important for this discussion or this group, needs to think about the air quality and the atmospheric composition work across all 6 of those networks, right? The person who's responsible for hydrology needs to think about not just being based in the Lowveld where they're sitting, but also what's going on in Cape Town or Kimberley or whatever. So it's to get that cross-link. And then each of the landscapes has got 3, the scientists and then 3 technical staff, which we hope will, at the moment is enough to kind of keep things going in terms of the instrumentation processes, the biodiversity, and also the social ecological systems and the engagement that's going on. And then SAON has its data nodes, which is at least archiving and supporting some of those data collection that we're doing.
Okay. Patients, Dr. Gwas, go ahead.
Thank you very much, Greg, for the interesting presentation. It's difficult to sustain research infrastructure, but it's necessary to have a research infrastructure for many years. Are you planning to collaborate beyond the sectors that you've identified so that this becomes superstructures, for example, long-term climate assessments and everything else? Or what are the timeframes? Thank you.
Yeah, so the SARIA program is for 15 years. We're a little bit less than halfway through that now. We are hosted within a almost national facility. So that's within the government structures to support research, and it kind of links in with the SAON mandate. As we get closer to, there's a lot of engagement with other structures and other groups around the country for this data and its importance. And I think that's going to be the last third of our time, is going to be figuring out how do we make sure that this remains funded and remains functioning. DSTI has put a lot of resources into the SARIA program, without them having made promises or signed contracts. It seems like they have at least the intention of keeping these things going in some format. So yeah, that's where we are at the moment, and that will be once it's established and it's proving its concept and the value of the research that's coming out. That's a business case that we're going to have to make, and yeah, continue to make.
Thanks for a great presentation, Gregor. I'm not sure if I missed this, but I didn't hear you talk about the data portal. So I only recently heard about that, and that's another amazing resource that you guys are providing. And I'm wondering, like, you also one of the editors of the Clean Air Journal, so maybe in your answer also reflect on that. I'm not sure the community always knows what the Clean Air Journal does for us, for keeping our knowledge local, for giving us this free platform to share research, and now coupled with that, another resource where we can really make sure our data doesn't get stored on some hard drive that will crash someday.
Not to say that anyone's hard drive or server is not going to crash. SAON is putting quite a lot of resources into its data platforms. It's through our Ulwazi node. There's the long-standing SAON observations database, which is largely designed around biodiversity data and things like that, but has also been capturing things like time series of weather and climate and things like that from the downloaded data. So where you go out into the field and you capture it, and that gets stored in basically a column per observation. What we've recently done is started taking this live streaming data that's coming through onto the websites and then feeding that into another data portal called the Terrestrial Observations Monitor. I did show a slide of it earlier, and the link is there, but you can also find it on the SAON website. And that is hosting the live streaming weather and flux data that's coming through from where we've got the information feeding into a server, into a logger, across onto the server, and then we're capturing that on that system. And yeah, you sign into it, you say, my name's Rulof, this is my email address, I promise to use the DOI. When I publish this, please remember to use the DOI because that's how we get credit. And yeah, you can download it in 5 minutes or 10 minutes or hourly data sets. I think close to 200 million data points.
My last question, how sure is your data in terms of traceability? I see you are measuring, and I think Patience was trying to talk about infrastructures that the government has put, and we see that some years ago, I think it's still there, SAQI is reporting these data, and we have been talking about the traceability, that it must be more accurate, and the companies that are here, possibility they are interested also in the equipments that you are using to measure these CO2s and NOs, but how sure is this data?
So, we're not a regulatory monitoring organization, so the broader ambition is not to get something like ISO 17025 accreditation that we could take to court or anything. It's for research use. But we are quite careful about the data that we use. The MET instrumentation is calibrated. We've got our standard operating procedures. It goes to NAMISA for our verification standards to be done on an annual basis. We don't, if it's past the 1-year expiry, we don't touch it until it it goes back. We've got a 5-year contract with NAMISA. The calibration gases for things like our eddy covariance systems, that's also a NAMISA standard certified CO2 gas and a zero that we use. So we've been trying to be quite careful in terms of ensuring that traceability. The metadata is also being captured and is being archived. So you can see our site visits, you can see what we did when we were in the field, and you can start seeing that.
Any last question from this side? I think it was more questions this side. You know me, I will name you, so rather give me a question. Okay, thank you so much, and we really appreciate. Thank you so much for this. You can take over to handle the panel. Thank you.
So you're not rid of me yet. I'm changing positions. I'm going to chair the next discussion on low-cost sensors. I think this is